Okay, now I'm recording. But it should be automatic, that's strange. Okay, good thing you said it. Now it's recording. I will share again. Okay, and now, from what I understood, almost everybody has TIA Portal installed. That's it? Everyone else who didn't say anything, they have TIA Portal?
I'm trying to install tomorrow.
Okay.
Because
so
I don't have time this weekend.
Right.
I send you an email if I have a problem.
All right. So follow the instructions like I told Martin.
I'm going to install today.
I'm trying to install
to
today
to be more accurate, you should say I'm going to try or
Yes.
to start installing today.
Yes, yes, that's
because,
right.
Yeah, don't count on being successful for sure, because
Okay.
some things can go wrong. Okay, but well, if you don't have TIA Portal, then you just see what I'm doing. The others can accompany me. Before we go into the practical part of the lesson, let's continue with the theory. And let me jump into, well, let me change my workspace here, so I can write down some stuff. And I was saying before, so participants, this you see, okay, my UC is SAI, and aulas teóricas, aula 1. Okay, so we go back to the PDF from last week. And you remember this, I hope so. So just to summarize what we did, we basically studied Boolean algebra. In particular, we've studied the table of truth, how we can manipulate or use the table of truth to derive a Boolean function for that particular problem, or for that particular table of truth. So that would be, for example, a table of truth, and then you try to derive the Boolean function. And we've studied also two methods to derive the Boolean function: the min terms, or the sum of products, and the max terms, and the one using max terms, which is the product of sums. We've also made a parallel between the logical functions and electrical or electronic ports, okay, or gates, and said that we can go from one to the other quite easily. I don't remember if we did an exercise with this. We will do it now. There are equivalents to the Boolean operations, equivalent logical ports, electronic logical ports. This would be the not, the negation, and so on. We've spoken about this. I'm not going to say it all over again. Then after we've learned how to, this is the part where, okay, just we can go further. So after we've learned how to derive a Boolean function, then we've studied all these rules, so the postulates of the Boolean algebra, which are used to simplify logical functions. And that's what we were doing last week. We've done a couple of exercises. I don't remember exactly which, but we've done a couple. I think it was these three, I'm not sure. And I'm not sure about what was your feeling when you were trying to do this, and if you tried more at home. You should, because this will be on the exam. But the feeling here, it's not just a feeling, it's the truth, is that this is not something which is straightforward. As you've seen, you can always go down multiple paths, and hopefully each of those paths will end up in the same simplified version of logical function. But it's not true. Sometimes you can go down a path which has no solution and which doesn't arrive to the same simplified version of the function, or as simplified as the most simplified version. So this part of simplifying logical functions is a bit tricky because there is no direct, and even more, when you are simplifying, you are really not sure. Again, there is no direct way of knowing if the function that you have at the moment cannot be simplified. Of course, with experience, you start being able to tell that's the case. But this is not straightforward, and that's why we are going to focus on the part of the class on something called Carnot maps. Okay, these are alternate ways of coming up. You are not watching what I have here. You don't have Carnot maps there, do you? Seems like I'm not sharing. I'm showing something here in my screen, but you don't see it. Ah, okay, now yes.
Professor,
Diga.
eu tentei fazer os exercícios, eu tive problema.
Ok, tá bem? A net está muito má, não está?
Não, gosto de...
Não os consigo ouvir direito.
Não consegue ouvir, professor?
Não, direito não.
Nós estamos a ouvir bem.
Eu pelo menos ouço bem também.
Sim,
Ok,
Estou ouvindo toda a gente, incluindo o professor.
ok.
Também.
Agora já vos estou a ouvir melhor outra vez. Talvez tenha sido assim uma paragem. Ok, então alguém falou, eu perdi-me aqui porque não estava a conseguir ouvir direito. Alguém falou que teve problemas a fazer exercícios. Tudo bem, já vamos lá, está bem? So just a moment, we will take a look at that. But just to say that I don't know if you've listened. So this Carnot maps methodology is a way of obtaining the simplified or the most simplified version of any problem, starting from the table of truth. So it's an alternative to the simplification of Boolean functions using Boolean algebra postulates, as we've done last week. But let's before we go into this, let's just take a look at a couple of more examples. So can you tell me what was the one that you have problems with? I don't know who was speaking.
Me. Nicholas.
Yeah.
When I
happened to you probably. Can you hear me? Can you hear Nicholas? I hear Nicholas like all cut.
Mas nós conseguimos ouvi-lo bem, professor.
Fine.
A minha
Assim,
ou
o
ao
Nicolás
Nicholas?
também.
Ao Nicholas não consigo ouvir. Nicholas, tente lá explicar outra vez.
I had problem with letter D and E. When I
So this one, this
allegation in De Morgan's law, I can't do this application. I go back to the start.
So let me try to do. So you were saying again, I didn't hear you completely, but this D, that's one of the problems that you have.
Yeah.
Ok.
Quando eu fazia a negação, dupla negação e a lei de De Morgan, ele voltava para o início, dava a mesma coisa, não simplificava.
Okay, let's try to do it. This one.
Okay.
Let's see if I can do it. Okay, now new. Aqui devia ser, so this is automation, and so this is exercise D, and let's try to put the image. So from the gallery, I think. Okay, should be this one. Yeah. Okay. So this should be. So this should be. First, let me just write it down. So y z not. I mean y not z, not x not z, plus not x not y, which should result in that one. Okay. So let me see what we can do here.
Teacher, just a quick question. In the exam, the question will be like this. We will have the results after the.
I'm not sure. It can be like this or without the second part, and you just.
Okay.
Yeah.
Because the problem of the second part is that, I mean, we reduce the equation, but we don't know if it's enough or if it's not.
Yeah, that's one of the problems of the Boolean algebra. With cardinal maps, you will be able to solve that one, I think.
Okay.
No, I don't know what I can do here. I'm thinking and thinking. So let me see. Do you have some suggestion about what we can do? I don't know what I can do here.
I was able to solve it, but I have to look because we use another.
Yeah, I can also search in my notes how I started this one, but I think I'm rusty. Let me try. Okay, let me see if I can find it. D. A, B, C, D. Yeah, funny. Yeah, I have here a pack of 50 sheets, and I was like, oh, how will I find this? And it's in the first page, but it's not solved. It's
I use the cardinal map because it was easier.
Okay. You're cheating.
Yes.
Oh, teacher, I know how to solve it, but we use. I mean, I looked something that we didn't use in the class.
Okay.
But I can try to explain it.
Just a moment, okay? Thanks for the help. Let me just take a look here at my. Yeah, I don't think I have here the solution for this one. So try to explain, please, and then if I cannot find it and cannot solve it, I will send it to you guys afterwards. So go ahead, try to guide me. How did you do it?
To write or okay.
To simplify this one.
Okay, so in the beginning we use x negated times z negated.
So you pick up this one?
Yeah, and then all that I will multiply times parentheses y plus y negation.
Okay. Which is 1, so you can do it, no?
Yeah, exactly. And then I can multiply.
So now you expand this one, no?
Yeah, but you are, yeah, exactly. We're forgetting that. Then we expand that.
That's it, no? Now what?
Yeah, now we can join y, the first one, with the third one. No, with second one. Sorry, with second one.
So
yeah.
y
Okay. Times z negated plus x 0. I'm sorry.
So this will be 1 plus y, no?
Just y.
Sorry. Just y. Okay.
Yeah. Just
so y. Now here z negated plus
x
plus x negated,
z
negated.
Yeah.
Okay. And the rest you leave as is?
No. Then x negated plus y negated.
No, you now you just for me to follow. Now you are putting these two together.
Yeah, but I'm
Alright.
putting the first one first. The last one I'm putting first. So it's like no y
last one.
negated.
Okay, so y negative.
No. Okay.
You are making me. You are confusing me.
I'm sorry.
Yeah, no
There is
problem.
x negated.
Here it's x negative.
Yeah,
Okay.
x negative.
Now you pick up that one. So
Yeah,
y negative
yeah.
plus,
Y negated plus
z negated, y negative. That's it.
exactly. And
Okay.
after that, c negated in the first one, c negated plus x negated, c negated is equal to c negated.
Exactly. So this one is equal to z negated 1 plus x negated, which is 1. So in fact, it's z negated. So in the end, this results in y z negated plus, so we can do the same here, I think. So this will be y1 plus z negated, which is the same as y. So plus, if I'm doing something wrong, tell me, okay?
No, it's just that. That's the
Okay,
answer.
what was this? Oh, great.
Yeah, but the
So
key was multiplying times y plus y negated.
Yeah. Thank you for your help. Zoom is having a problem. It's not only me. My colleague, another professor, had the same problem. It's since yesterday. It seems like I don't have the professional license. I should have, but I don't. And what we will have to do is when the meeting goes down, we come back again. Okay? I just turn on again the meeting.
Okay, but the teacher is going to record all the videos, right?
Yeah, remember me to start recording.
Okay.
Once we.
Teacher, just one question.
Yeah.
I don't understand the first part. Why did you use the y plus not y after the z?
I think the difficulty in this exercise, which is this one, that's your question.
Yeah.
Is that we are used to, so we have an expression like this, and we are always going down shrinking, so it becomes smaller and then smaller and then smaller. In this case, and that was the difficulty, you have first to enlarge it in order to be able to shrink it afterwards.
Yeah.
Yeah, so why do we do it? Because if we do it like this, then we can do all the simplification.
Yeah, but I just don't understand what law did you use to write that?
We can search for it.
Like,
yeah, let's search for it. I don't know the name by heart, but we can search.
The thing is that, teacher, that's not a rule that we had in classes. I have to look it in the internet, and then I understood that, and that's what I use it. But it's like multiplying times 1. So
no, but I think you can. Are you sure it's not here?
Yeah,
it's here.
I mean, yeah, but it wasn't like that, obviously.
Yeah, but that's the rule, no?
Yeah,
okay. We're just basically multiplying it by 1.
Yeah.
It was already multiplied by 1. We just replaced it by a plus not.
Okay. But why did we use the y? Why not an x or a z? It would be the same, or?
That's the problem with the. Well, your colleague should answer, not me.
I had to try with some of them, and then in the end I got it with y.
Oh, but you tried with x and z. We have to. That's it.
I mean, the thing is that, for example, in the second one that I used, I have x and 0. So the only one left was y. But before that, I tried with the first one that I had y and 0, and I had to try with x. So try to join to the other factors, and then I can simplify.
Okay. Thank you.
It's a bit like this, that my drawing. You never know where you should go. I mean, then you can start a mission, but that's the problem with the simplification, because you really don't know if you are going into a dead end. If you get into a dead end, you have to come back and try another way. But it's not automatic. It's just trying and getting a feeling. That's why I don't like this part so much, because it's not, it's, as I've said, it's not automated. It's just trying. Okay, so more questions. Anybody? No? Let's try another exercise.
Yeah, teacher, I wasn't able to make the last one, so I think that's hardest.
Yeah, it should be. It should be very hard. That one, let's not waste, because we might be stuck there for a long time. So if you cannot do it, just send me an email with what you've tried, and I can try to take a look offline. Okay. And let me just see the last one. You mean E, or do you mean the last one like?
Leather, the other one, leather E. Yeah.
I can try to search it, but I thought you meant the last one.
No, it's leather E.
Yeah.
I think.
Okay, let's see. Letter E. I think I have it here. Let me just check. Not sure. Well, I can send it to you afterwards, okay? Just send me your attempt. Take a picture, send me your attempt, and then I send it back to you, okay? Can you hear me?
Okay.
Okay.
Yeah, teach.
All right. So let's do something else that I wanted to practice with you as well.
Just one question.
Yeah, go ahead.
Does the teacher has the answers of the other problems?
Of some of them I do, because I have to derive them. But
the thing is that I tried, I simplified some of them, but I don't know if it's enough. So
yeah,
I don't know when to stop.
If you send it to me, I will
take a look.
I can take a look. Okay.
Okay. Thank you, teacher.
I wanted to try this one. Okay, so let's try this one, which is to have, we have the table of truth. I want you to derive the values, the values. I want you to derive the logical function, and then to simplify it. Do you nobody has a pen which you can write with, no? Because I wanted to ask your collaboration, but no one can write, no?
I guess you have to give us that permission.
No, but the problem, you already have the permission. You can annotate directly. The problem is that, yeah, but with the mouse you cannot write. That's the problem, you see. So if you just have mouse, then I have to do it. Okay, but I will ask for your help. Okay, so, okay, let's cut this one. Okay, save. Now we go, and we go back, a new one, also automation, and I don't remember which was the slide. Let me take a look at the slide. Slide 50. Slide 50. Okay, now we insert an image from the gallery. That's the one. Actually, we could perhaps, it's quite big, no? Okay, but I think we can manage. Okay, so we first thing we have to derive the logical function, and we do that by using the min terms or the max terms. Let's first do it with the min terms, okay? So, oops, right. I cannot write here. Why not? Save. Okay. Edit. Oh, come on. I don't have the. Okay, now yes. Okay, so mean terms first, which is the sum of products. So I don't know if you remember, but we have to pick up all the places where the function is true. So we will pick up mean term 0, mean term 1, 2, 3. We will also pick up this one, and this one. So our function will be not x, not y, not z, because they are 0 in this first row, plus not x, y, and z, okay, plus x, not y, not z, plus, so I'm here now, only the last two are remaining, so plus x, y, not z, plus x, y, z. Okay, so this is our Boolean function. And anyone has, anyone has any questions concerning this one? So this is okay for you.
Okay, I am back.
Now you can hear me, no?
Yeah.
Yeah.
All right.
Yes.
Okay. So we are back. Sorry for the inconvenience. And just one more thing that I should not forget is to record. Oh, it's already recording. Okay, so let's just record this one. And we go back to where we were, which was solving that exercise. This one. So we use the mean terms in order to come up to this solution. By the way, this function is called a function in canonical format. Canonical format or form. Why? Because this is the fully expanded, directly taken from the table of truth function. Okay. Now we have to simplify, and to simplify, let's see how we can do it. So I would say that we can put together, let me think, we can put together these two, and the result will be xy. Everyone understands why? Because we will have z, not z, plus z, which is the same as 1. Then we can put together, let me see, in another color, this with this, and the result will be, so the difference is the x will be not y, not z. Everyone agrees? And now we have a third case here. Which we can put together with this. Okay, so take notice, this one here, the one which is underlined in orange and yellow, is actually being duplicated. You know that I can say something like this. I can say x, y, z equals x, y, z plus x, y, z. So that's why I can use 2 times that term x, y, z, okay? If you are not following, please interrupt. And so the yellow part will result in, I think should be a darker yellow. Let me put red, okay? Easier. So the red part will be YZ. Okay. And I think that's the end. I mean, again,
I didn't understand the last part.
This last part you didn't understand? Okay, so let me write it like this. So this is the orange, right? Until here you understood, right?
Yeah, yeah.
Okay, so now I can pick up this one, X, Y, Z, and create 2 terms, because I can say A equals A plus A, correct?
Sure.
This part, do you understand this one?
Yes.
Okay, so I can say here plus X, Y, Z, correct?
Yes.
Professor, mas você já usou esse X, Y, Z, não seria o outro, o de cima? Not X, Y, Z?
No, that one was, okay, so
The
I
second
will,
term.
yeah, just a moment. Let me try to do it with a little bit more, in a different way, okay?
Okay.
Better. Perhaps I was going too fast. Let me try to go slower. So this will be not X, not Y, not Z, plus not X, Y, Z, plus X, not Y, not Z, plus X, Y, not Z, plus X, Y, Z. And now, because A equals A plus 1, equals A plus A, I can say, I can put here another X, Y, Z, correct? Do you understand this one? I just duplicated the last term, correct?
See.
Now I just put combinations of those. So first combination was, I have to check again. I think it's the first and the third. So okay, so this one combined with this one, the only difference is X. So this results in Y, Z. Okay, do you understand this one? If not, I can show it like this. It's like this. Okay. Now, second one, magenta one, will be this one and this one. And that results in okay. Third one. Did you understand now?
Yes, teacher.
All right. I was going too fast.
No,
sorry.
I just remembered I had 2 questions about the exercise I made. The first one is, for example, if we have A times B times C plus, no. For example, if we multiply some letters, and there is one A and one A negative, all of that is 0, right?
I'm not sure 1A and tell me again. But just a moment. Please ask me. So this is not directly related with this exercise, correct?
No. Yeah. There's another question.
Let's talk about it afterwards, okay? When I finish this one, we go back. Otherwise, we are interrupting. It's not a good idea, okay? Don't forget to tell me after we finish this one. So after this, we result, what we have is not y, not z, yz plus xy. So I can write it down here. Again, not y, not z, plus yz plus xy. Okay, so that's the simplified version. Let's call it fsimp. The simplified version of the logical function that represents this table of truth. So far, so good. Don't remember that the exercise didn't finish here. It also said, so get the logical function, then simplify it, and finally draw the circuits, the initial and the simplified. So I'm not going to draw the initial, it's more complicated. I'm just going to draw the simplified one, okay? So to draw the simplified circuit, we take a look at this function. And I don't know if you remember, but let's just recapitulate. This is an and this is an OR. And this is a NOT, okay? So this is what we need to know. My drawing is horrible. So, OR, yeah, OR. So what we have to do? Look, here we have not Y, not Z. So we have a line that is Y. We have to negate it. And then we have another line, which is Z, which we have also to negate. And these two, so multiplication, which is here, is the same as an AND. Okay? So this part here is this one. Now we have another one, which is YZ. So the YZ part, which I'm going to put in red, the YZ part is Y times Z. So again, we will have an AND. And we have to do the AND of the Y signal. So the Y is this one.
Y.
I don't know if you understand this notation. When I put here a circle, a dot, that means there is a connection. When I don't put a dot, which is the case here, that means there is no connection, okay? It's just a crossing without interference. So that's the Y input, and then we have here the Z input. Okay? What else is missing? X, Y. So XY is the same as YX. So we can do here the Y first. So the Y is this one. And then here we have the X. Oh, sorry. Okay, so that's the YX. And finally, there is the OR of all these three parcels. So the OR, which I will signal in what other blue. Okay, so I still have the blue. So the blue is the OR. Okay, and finally, this is F simplified. So I write here typically F simplified. Makes sense? Any questions? I'm trying to change the zoom, but I cannot. So, but I think it's easy to do, no? Of course, it can be quite large, the circuit, because if you will do this exercise for the first function, the canonical form, of course, the circuit will be quite large, right? Any questions? So this part can also appear in the exam. So you should be able to go from the table of truth to a function, or from a circuit to a function, then from a function to a circuit. You should be. This is all. You should be able to go to do all the possible combinations. Okay. So much silence. Are you still alive?
Yes.
Yes.
Okay. Alive, but
Yes.
not very happy. Okay.
Barely
Continuing.
alive.
Barely alive, correct. Continuing. Let's see. I will save this exercise.
Professor.
And let's. Diga.
Em vez de fazer esse com o max termo, você podia fazer um de circuito para função. Eu acho que tem é o anterior a esse, né?
So you wanted me to try to do
circuit com equation.
Let's see. This one? No.
Yeah.
This one?
Yeah, this one.
Okay, let's try to do this one. So this one, that's a good idea. And that's let me check my time. So 50 minutes. Okay, so then we have to go to Carnot maps. So this circuit from equation, I'm trying to see if I should draw here, but I think I will again copy this. Okay, copy. Now a new Samsung. Okay, this is automation once again. What slide was this one? I forgot once again. Slide 49. Okay, now we try to insert, so we can save the note, edit again. Now sorry, better like this. We insert the image from the gallery, this one. Okay, here it is. Now, so the way I do this is something like this. So first we know there will be a big plus because it's here, no? This is an OR. So you will have a big plus and then a negation. Do you see this circle there? That means a negation. So it should be something like this. Okay? This part here should be here, and this part here should be there. Makes sense so far? I hope it does. So
yes,
the purple part, I think it's more simple. So let's start there. So there are two ways. What I'm going backwards. So from the end to the beginning. So from right to left. But you could also do it from left to right. Well, I just started like this, so let me try to finish it like this. So the first is, oh, sorry, there is something missing here. Was this a problem of copying or what? It's here, it's missing, do you see? So this one should go there. Okay? Don't forget about this. So this one, it was missing in the exercise. So again, I will do it like this. So this is not a okay, so again. So this OR is an OR of 3 parcels. So we have here another parcel. Okay? So the first parcel, the middle parcel, which is that one, is not Z. So it is Z. You can see my mouse, no? No, you cannot see my mouse. So it's Z and then negated. So this is not Z, the middle one. The one in the bottom, this one, is an AND, so a multiplication of the one on top is Y and the one on the bottom is Z. So basically Y, Z. So far, so good, everybody. Let's continue. We continue to the red part, the difficult part. So the difficult part, we can just do it here. So the difficult part should be, again, here we have an and, so we will have to have a multiplication of something with something else, okay? The first something, which is on the top, is the x. So this will be x multiplied by everything that I will put in blue. So x multiplied by this one, right? So let me try to rephrase this. That way we will have more space. So we will have x, which is this part here, multiplied by something. And the something is the blue part. So the blue part is an OR. Actually, the blue part has here a circle, so you have to negate it. It is an OR, so there is a sum here. On one side, on this upper side, we have the negation of x. On the right, on the bottom side, this one, we have y times z. Okay, so now we just have to put this part there. Let me do it. So the solution would be x negation of not x plus yz, okay, plus not z plus yz. Okay, so I think this was the solution. Any questions? You could also do it not from the end to the start, but the other way around. You could try to go from left to right, okay? Was it clear? I think it was I forgot the name. Sorry, so many stuff. Nicolas, that you were asking, no? Or am I wrong?
Yeah, that's okay. I just forgot the not of the all solution.
Okay. Okay, so now let's jump into the cardinal maps, because otherwise we will not have time. So again, you should do these exercises. That's the kind of exercise that we will have in the exam. Don't forget, the exam is not online. I mean, you have to do it online, so you should be on your computer, but you will have to be in the university. So I'm booking a room for you to be there. You should bring your computer. If someone has a problem with not having a computer, they should tell me in advance, okay? But don't forget, 6th of November. So 15 days from today. Let's go now to the PDF. And we are going to start talking about cardinal maps. And so again, cardinal maps are a way to visually, by a visual inspection or a visual analysis or procedure, a way to obtain the most simplified version of a table of truth. And the good thing about this is that this is straightforward. So you can easily automate this procedure without any problem. So let's start with this example here. This is an OR. You can see. So you can imagine a table of truth like this. So X y, 0, 0, 0, 1, 1, 0, 1, 1. So if this is an OR, when we have two zeros, it's 0, and all other cases, it's 1. So this is the table of truth of the R function, okay? Makes sense. And what we do in the kernel map is to organize the table of truth into a map. That's how it's called, a kernel map. And the kernel map will have the variables entering on the as columns and has rows. Okay, so here we put the X there and the Y there. Notice you can actually swap them and the results should be the same, so that wouldn't be a problem. And then you just look for the combination. So when X is 0 and Y is 0, you go here and you say, changing colors. So when X is 0 and Y is 0, you go here and 0, 0, that's it. So that's how you put this 0 there. When X is 0 and Y is 1, we are in this case, and that's why we have a 1 there, and so on and so forth. So you are just filling the table with zeros and ones according the table, no, the kernel map with zeros and ones according to the table of truth. What you are actually doing is you are putting min terms here, okay? And you can actually check that those are min terms, because if you do the analysis, you will come up with this expression here, which is the expression for the min term. So if you do this min term, and that min term, that's the function that you have. Of course, this is sorry.
Teacher, can I ask something?
Of course.
Kernel maps are always with the min terms?
Yes, I think so.
Okay, thank you.
Okay. Of course, that you can say, oh, if this is an OR, the function for the OR is X or Y. The function for the OR function, the intuitive version of the function is X or Y. However, we have all this thing here with the min terms. That's because this is the non-simplified version. So from here, we should be able to go to the simplified version, X plus Y, okay? And we can actually do it if we do the simplification using Boolean algebra. So you can see here, but you can see here how to do it. In the end, we get the result that we wanted. This is using Boolean simplification, Boolean algebra simplification. What we've learned so far. But of course, this is a very simple case. In more complicated cases, this simplification is not so straightforward. The way to do it using kernel maps. So this is what I've said before. We have a visual procedure for the simplification, and the basis of all this is to find or to identify neighboring products. Okay, so this is the key, neighboring products. What does it mean? It means that you remember that before we had our kernel map 0, 1, y, x, 0, 1. It was like this, 0, 1, 1, 1. So where you have ones, you have to group the ones. You have to make groups of ones, and these groups will do the simplification. So, for example, in this case, I have a group here of ones, and this group of ones. So if you take a look at this, in this group, in this yellow group, y is always 1. And x can be either 0 or 1, it doesn't matter. So that's replaced by a y, okay? Let's now do the other group, for example, the blue group. In the blue group, you can see that x is always 1 and y can be anything, 0 or 1. So this is x, okay? And f equals x plus y is exactly what we had achieved with the algebraic simplification and actually what makes sense for an OR function. So this is the procedure to identify neighbors. And how can you identify these neighbors? They should be of size 2 to the power of n. So the neighbors cannot be of 3 elements or of 5 elements. No, they have to be either of 2 elements or 4 elements or 8 elements or 16 elements and so on and so forth. And you can do this cardinal map not only for 2 variables, but for 3. For example, this is another example. You have here the x on the columns. Then you have the y and the z on the rows. Sorry, the other way around. So x is on rows, y and z are the columns. And then we put here, of course, because now we have here 2 variables, we have 4 entries and not just 2, because there are 4 combinations of 2 variables. So this is when 0, 0 means y is 0 and z is 0. 0, 1 means y is 0 and z is 1, and so on and so forth. There is just one trick in the cardinal maps, which is this one. This is very important because we are searching for neighbors. And because we are searching for neighbors, it is very important that we put the combinations in a way that we have neighbors. So notice there we put 0, 0, 0, 1. From here to here, what changed was only z. Y remained the same. Then here we put 1, 1. And the only thing that changes is the y. And then the next one will be 1, 0. And the only thing that changes again is the z, okay? And you can say, well, but why are you doing this? Why don't you put 0, 0, 0, 1, 1, 0, 1, 1, okay? So we could think of doing something like this. The problem is if we put the variables like this, in this sequence, this is not a neighbor, okay? Because from here, from this one to the other, you have a change in 2 variables. In the first one, which is the y, and so it goes from 0 to 1, and you also have a change in the second variable, which was the z, which goes from 1 to 0. So you cannot do this in the cardinal maps. You have to make sure that you always have only one change from one column to the other or from one row to the other. That's the only trick about cardinal maps. Let's continue. Okay, so this is what I was saying. Be careful. Oh, no, this is not what I was saying. This is something else, which is doing neighbor groups is not just about doing, for example, this. Let's put red color, it's easier. It's not just this. It can also be neighbors over the edges of the table. For example, I can say that this is a neighbor of that, okay? It's as if those, do you play that game Snake? Where you would go to one side of the screen, to the right-hand side of the screen, and then you appear on the left-hand side. It's like that, okay? It can also be vertical. So here you have some examples. Let's not take a lot of time with this. So doing the simplification in the cardinal map is a matter of finding the best groups. The rule is to try to achieve the smaller number of groups with the largest size. That's where sometimes people fail. We have to search for the smaller number of groups with the largest size. For example, here, take a look. We have found this group here, and then we put this one with that one. And notice, we didn't do it like this. Yellow better. So I think like this is better. So we didn't do it like this and this. Why? Because if we do it like this, we would also have to have a third group to account for that one. It could also be a third group like this, but the problem is that we would have 3 groups instead of the original solution, which had 2 groups only, you see? So the blue solution was better than the yellow solution because it has less number of groups. Also, you cannot do, let's call it the orange solution, which is this. Why not? Because the group on the bottom has 3 elements, and groups can only have size of 2 to the power of n. So it can only be groups of 2, of 4, of 8, and so on. So 3 is not possible. More examples. So you have some examples here. You can review the slides and see how it goes. We will do some exercises for you to see. By the way, let me check the time. Okay, we have time. With 4 variables, it's something like this. It's more of the same. I mean, there is no problem. We will do some exercises. And so this is what I was trying to explain. So the way to do it is to group the ones in the Carnot map into sets or groups of 2 to the power of n elements. And you search a solution in which the groups are less in number and as big as possible. So less number of groups, the largest possible groups of the largest size possible. Here you have some example. For example, you have here, for this particular problem, you have the red group, and then you have the green and the blue. One important thing also is that you can use ones multiple times if that serves the purpose of getting larger groups, for example. You can see here this example. We have this table here, this Carnot map here. So 1, 1, 1, 1, 1, 1, 1, 1. I'm just writing the ones, okay? The zeros I don't write. Actually, I can write the zeros. It's easier. So it doesn't matter the variables. It is there. But I was just proposing a different way of finding groups. You could come up with this idea. So red is this one. And then we have, so this is the red, let's call it the red solution. Then this and this. So this solution has 3 groups. So it should be F equals something plus something plus something. Tell me.
The last one that you choose, can it be just alone? Or
yes, it's a group of 1. As I said, the groups can be of power of 2 to the power of n. If you put here 0, it will be 1. Okay, so when n is 0, this is 1. Okay, but this solution that I'm writing here is not as good as the one that is highlighted in the slide. So this is better. Why? Because although it contains also 3 groups, the groups here are bigger than the groups that I will have. Because this solution has 1 group of size 8. Then 2 groups of size 4. My solution here has 1 group of size 8, 1 group of size 2, and 1 group of size 1. So you see, this one is better because not of the number of groups, but of the size of the groups. You see? Any questions? No? You can also know that if so now I will teach you how to derive the variables, so the parcels for each cell or for each group. If you have a single cell, so a group of 1, you will have 4 literals. This is for a Carnot map with 4 variables. If you have a region of 2 cells, you will have 3 literals. If you have a region of 4 cells, you will have 2 literals, and so on. For example, let me just do an example. So let's keep with this example. And suppose that I have the groups that I draw here. So I have this big group, which I will call blue. Again, don't forget, the groups that I found here are not the best groups. So this is not a good solution, but it is good for us to practice how to derive the function based on these groups. Of course, we would have to select better groups, not these ones, but just for the sake of practicing how to get to the function after selecting the groups, we have the blue group, which is actually a bad example because, sorry. So the blue group is the same as this one, no? So the blue group is the following. So Y can be anything, X can be anything as well, so it doesn't appear. Then here, Z can be anything because here is 0 and here is 1. And we only have, the only thing that is always true, is always the same, I mean, in this red group is not Y. So that's why we have not Y plus, so another group. So don't forget, this blue group that I have is the same as the red group here. So that's why my not Y is the same as this not Y. Second group, let's call it the purple group. So the purple group will be, if you take a look here, take a look, the X always changes for this purple group, correct? So if it changes, it doesn't appear. But the W is always 0. So you have a 0 there and a 0 here. So this will be W, not W because it's 0, not 1, not W. And then on the vertical side, you have 1 for Y, so Y, and you have 0 for Z, so not Z. Again, a group with 2 cells, we have 3 variables, W, Y, and Z in this case. Finally, we have the last group, which I will call the yellow group, which is this guy only. So this guy only, because it's an isolated cell, we will have 4 variables. So let's take a look at those 4 variables. So in this yellow group, we have W1, X1, so WX. And then if we do the vertical analysis, we have Y1, Z0. Okay, so this will be the logical function derived after those groups, which were not the best again. Any questions? No questions? Okay, I'm afraid you.
I didn't understand. What did
You
you
didn't
understand
you didn't,
that?
Okay, which part in particular?
Yeah, this. You can explain the big one, the why, not why.
Okay, I will explain in a different slide with an exercise. It will be easier. Okay,
okay,
Nicolas?
Okay, it's better.
Okay, yeah. So again, these are the adjacent groups. You can take a look at this. Let's go. Let's do a full example. That way, I think Nicolas will be more clarified. So this is a table of truth with 4 variables, not X, Y, Z, but X, Y, Z, W, but A, B, C, D. And let's try to solve this one. So first things first, we create a cardinal map. How do we do it? Let me choose another color. Okay, so let's put AB here and CD there. Okay. Now we have 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay, so far so good. Now, remember I told you, be careful about the way you put these numbers here. So for AB, we will start with 0, 0, 0, 1, 1, 1, so that there are neighbors, they are neighbors, 1, 0. Same here, 0, 0, 0, 1, 1, 1, 1, 0. So far, so good, no? Now you can even think of it like this. This region here, so all these region, all these two rows are the places where we have a positive, correct? All these regions here are the places where we have a negative, because we have here 0, 0. So, and you can do the same for the other variables. For example, this group here are the places where B is positive, and this and this are the places where B is negative. Okay, so you do understand this, either the horizontal analysis or the vertical, it's the same. I could do here the same for C and D, but I think you got the picture. Now, next step, what do we have to do? We have to look at the function here and see where we have ones. So 0, 0, 0, 0, we have a 1 here, right? Let's add it. So 0, 0, 0, 0, 1 here. Then we go to the second one, 0, 0, 1, 0. 0, 0, 1, 0, it's there, correct? Now this one, 0, 1, 0, 1. So 0, 1, 0, 1, it's here. 0, 1, 1, 1, 0, 1, 1, 1, there. I'm not doing the zeros, I'm only doing the ones. Now this one, 1, 1, 0, 0, 1, 1, 0, 0. This one, 1, 1, 0, 1, 1, 1, 0, 1. This one, 1, 1, 1, 0. And finally, 1, 1, 1, 1. Okay, so far so good? Nicholas, you don't have any problems until now, right?
Right.
Right,
It's okay.
So now we just have to do the groups. So Nicholas, I will ask for your help. Tell me, which groups are you thinking about? Can you annotate? Can you draw in my screen? If you go to your, there is an option called annotate. If you select it, you can start drawing. Can you find it? I'm not sure it's available for you.
No, we can.
You cannot.
See. No.
Okay, so try to describe it. So, which groups are you thinking of doing? Tell me.
I think the third line with all one.
Good idea. So let's start with that one. Okay, so this one. Then
the second line with 1, 1.
So that will be the green.
And the first line, 1, 1.
So you mean this, right?
Yeah.
Okay. Any other colleague has a better idea or not?
Yes, I have.
Yeah.
Instead of the green being 2, we can make a square, right?
Right. It can be bigger.
Yes.
Oh, yeah. That's. I was trying to. Yeah. Perhaps I can undo. So what Francisco was saying is this. So the green, instead of doing what you said, Nicholas, it can be like this. So it's bigger, right?
You can put the numbers.
Yeah, you can use them. You can use them more than once.
Okay.
That's because of what we studied before. So A equals A plus A. So you can actually use this mean term more than once. Okay.
Teacher, just one question. In the end, you have to use all the ones, right?
Yes, you have to use all the ones. I forgot to mention it. You have to. All the ones must be inside a group. But the ones can also be in more than one group, but they have to be at least in one group. Okay, so now we have this, and now we can derive our function based on this, our logical function. So let's start with the blue, okay? So Nicholas, tell me the blue. Can you tell me the equation for the blue? For the blue group, I mean.
It's not A.
Not A, correct.
Not A, not B. No.
Yes, correct.
Yeah.
Yeah.
And not C. No, C, not D.
C, let me see. C doesn't appear because C
Oh.
is 1 here and is 0 there. So it doesn't appear. Right?
Yeah, this part I can understand. Why?
Because it's the same as saying. So it's the same as, so let's, the D, you agree that it's not D, right?
Yeah.
So if you want to put the C, you would have to put it like this. Ah, it can either be C or not C, right?
Okay.
And this cuts to 1.
Yeah.
All right. So now you understand when you have variation, you don't have to put it, right?
Right.
Okay, so continue, Nicholas, please. Tell me the green group.
Okay. B.
B, exactly, because it stands. So A is not A plus A, so it doesn't appear.
Yeah. D. It's all right. Because
D, yeah. BD. That's it, no?
I think so.
Do you agree?
Yeah, I think.
Okay, so let's do the red one.
A.
A, correct.
A and AB.
Yeah. Anything else?
I think I put C and D too, but I don't know.
Yeah, but again,
That's
C.
hard.
So C can be,
Okay.
you can put C like this again. No, because in the red group.
Yeah.
Yeah. So
I have 0 and 0. Okay.
Yeah. Not 0, 1.
0 as because
One.
we have yeah.
So again, a group with size 4 results in 2 variables. So the green also has size 4, so 2 variables. A group of size 2, 3 variables. If you had a group of size 8, 1 variable only. If you have a group of size 1, 4 variables. Okay, so the important part of this is that this function, not A, not B, not D, plus BD plus AB, is the most simple version of the function. So if you want to take the time, you can use this table of truth to derive the canonical algebraic function, then use the algebra logic to simplify, and you will result in this. Okay, that should be the solution. And that's the good thing about the Carnot maps, because they are quite easy to do. It's really not that hard, and in the end you find the solution quite straightforwardly.
So this is the simplified solution.
Yeah, this is the simplified, not only the most simple solution.
Yeah, right. Okay.
Well, not the most simple, one of the most simple. Sometimes you can have more than one with equal simplicity, but you are sure that this is one of the most simple, okay? I mean, if you did the grouping correctly, if you did the grouping incorrectly, like I did here, you can see this function here is more simple than my function here because I did bad groups. So I didn't do proper grouping. Okay. So grouping.
Teacher, sorry, just one thing. I disconnected when someone asked if the f was the simplified simplified the function, what did you answer them?
I answered that you can be sure that it is one of the most simplified versions. Sometimes you can have two or more solutions with the same level of simplification. So it doesn't guarantee that's the most simple solution for the function, but it guarantees that it's one of the most simple solutions, okay?
Okay, thank you, and sorry.
No problem. So what else can we do? Perhaps another exercise. Oh, it's here. You don't notice here it's different. It's different from this solution here. And why is it different? Because he put AB on the top and CD on the bottom, you see? And then he goes on to do what we did. Sorry, he does the same, but in the end, his solution is this one. So not A, not B, not D, plus AB plus BD. And that should be our solution. Not A, not B, not D, plus AB plus BD. So different order of the variables in the Carnot map, same solution. Doesn't really matter, okay? Of course, you have to create groups differently. Okay, so now...
Teacher, I just have one question.
Go ahead.
For example, we have 5 parameters.
Yeah, 5 parameters is good. Above 4, it's more challenging. But with 5, what you do is what we have here. No, not this. I think there is a slide here for 5. Here. So, mapas com mais. Yeah, that's it. So look, this example here. It's a good thing you ask because it can appear in the exam. When you have 5 variables, what you do is you do one map of 4 variables for when one of the variables is 0, and another map for when one of the variables is 1. But then you also have to consider neighboring neighbors over the third dimension. What do I mean? I mean like this. So if you have 4 variables, you will put it like this. And so this slice here is for A equals 1. Then you have a second slice there. And this one is for when A equals 0. So you see, it's as if you have 2 slices, but now be careful because you will have to be able to find not only groups in each of the maps, but also you can find groups with this kind of neighborhood, you see? Martin, did you understand? No?
Yeah, I kind of understood, but...
Yeah, but it's very difficult with 5 variables. With 5 variables, it's more difficult.
Okay. Just answer me one more question, teacher.
Go ahead.
We have, for example, when we have just third variables, it has to be in one side A and in the other side B, C, or we can put in whatever order we want.
Whatever order, it's the same as here. Here we selected a different order from the solution, and the result is the same.
No,
so if you have, for example, forget about this the D. You just have ABC. You can do a cardinal map like this, ABC, or you can do like this, ABC, or you can do like this, ACB, whatever you want. Okay. The result will be the same if you do it correctly.
Okay.
Any more questions? No? Okay, so let me see the time. So we have an hour and a half. Yeah, so I will go forward. And then we are going to try to go a bit to tier portal. So I will not stop here. This is just an example that I would like you to study. This is called a decoder from eggs to 7 segments. So eggs is the hexadecimal representation for the numbers. You know that it goes from 0 all the way down to F. And you have basically 16 possible values, no? No, 16 values. What we are going to do is to, or what this does here is to, so 16 values, you can use 4 bytes. No, not bytes, sorry, bits. Bit 3, bit 2, bit 1, and bit 0. So 4 bits are enough to represent 16 values. So you have these 4 bits here. 1, 2, 3, 4. So 4 bits will provide a binary representation of a number, which then will have an hexadecimal representation. So, for example, if this is the values for the B3 through P0, then we have hexadecimal number 9. Another example, if we have this combination of values, the hexadecimal value is D, okay? So the idea is that we have an input of 4 bits, the state of 4 bits, and then we have to select whether or not to highlight a segment, S1, S2, and so on, in order to show the number like this. So that's what the decoder does. Now, we don't have a single Boolean function, so it's not just an F here. There will be a function for each of the segments. So for the segment 1, okay, so I will put here segment 1. Segment 1, which you know that is here on the top. So this one here, this guy here, sorry, I'm saying this guy here will turn on when we have number 0, when we have number 1, no, number 2, yes, number 3, yes, number 4, no, number 5, yes, number 6, no, number 7, yes, number 8, yes, number 9, yes, A, yes, because A is like this. So yes for A, yes for B, and so on. So this is the table of truth for segment 1. You have a table of truth, you go to the cardinal maps, you obtain a simplified version for segment 1. Then you have to do the same for segment 2, and blah, 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 until segment 7, okay? So what are you doing here? You are finding logical simplified functions using cardinal maps for each of the segments, when those segments should be on or off. You can take a look at this example carefully. So this is the derivation and the cardinal maps for each of the segments. Again, here are for example, if you are with the E, then you should put segment 1 on with a 9, also segment 1 on. A 4 doesn't have segment 1, and so on and so forth. And so this is a complete derivation, which you should study for this eggs to 7 segment decoder. But the idea is always the same. It's just to do cardinal maps for each of the segments. Let's, for example, do the cardinal map. No, actually, the cardinal map appears later, I think, or not, or just for this. Okay, so let's, for example, do this cardinal map for segment 5. Okay. Okay, who volunteers? Who can tell me which are the better groups in this case? Come on, I need some volunteers.
Okay, so we have the first I see is the 0000 with 0010. Like the four corners of the.
Okay. So this is a group. This is sometimes people don't see this one, but this is also a group of 4. So very good, Francisco. This is the first one. So let's call it the group, the red group. Now another.
We have B3, B2, 1, 1. The
Sorry
third
again.
column. The third column.
Like this, no?
Yes.
Okay, good one. Next.
Then we have in the last line another.
Yes.
And then we have the square.
Exactly. I think that will be the best solution. I always have to think a bit to see if I'm not forgetting a better solution, but I think no. I think that this would be the better solution. So, and from this you would derive a function, which would be something like, I think I can do it. So the function will be the red part. So the red part is, okay, so B1 is 0, 1, so it changes, but B0 is always 0, so not B0. Then on the vertical analysis, B3 changes, so here it's 0, here it's 1, so B2 is always negative, so not B2. This is the first. Then, for example, for the green, the vertical analysis, because the green occupies all it's a full column, so all the rows are occupied, so it means these two don't matter. And it is when B3 and B2 are on, so B3, B2 plus. Let's go to the blue. The blue is the same, but in the different axes. So again, because it's a full row, the columns don't matter. So B3 and B2 don't appear. And B1 is 1 and B0 is negative. Finally, we have the magenta one. The magenta one will be B1 and B3. Please tell me if you agree. That's it, no?
Yeah, that's it.
And this will be the function for segment 5. Okay. And so on. I recommend that at home you start trying to do this kind of stuff, and if you have time, even do it for all the segments. It's interesting for you to learn more. Okay, so let's continue to another case, another extension of the Carnot map, which is the don't cares. So actually, sometimes you can be doing a function in which some of the cases don't really matter. So you have, for example, 4 variables, which is 16 combinations. So again, if you go back, so here you have 16 combinations, these 16 rows, and you always say, oh, if this is 0, 0, 0, and 0, it's 1. And if it's 0, then it's 0. So you always say if the function should be true or false for every case. But sometimes in some applications, there are some combinations in which it doesn't really matter if it's true or false. Let's call those combinations don't cares and denote them with an X instead of a 0 or 1. So there are some rows in the table of truth which can have X's instead of zeros or ones. So the definition is combinations of variables which are irrelevant, which can not occur, or that if they occur, it doesn't really matter. The output in this case, it doesn't matter the value of the output. That's why you represent it with an X. An example. So here you have another table of truth in which you have a lot of X's, okay? How do you simplify the Carnot map when you have X's or don't cares? So you handle the don't cares has a 1 or has a 0 according to what best suits you for the simplification. So if it's good for you that the X is 1 because the group will be bigger or because you will have less groups, then the X will be 1. However, if taking that X as 1 will just increase the number of groups, then you don't do it. For example, in this case, we have used this hex here that I'm highlighting is being used as 1. Why? Because if we consider it as 1, we have this large full column group. Same for these two x's, they are considered 1. However, for example, this x here is not being considered 1, because if we consider it 1, then we need to have a group for it. And if we have a group for it, it will be one group more than the best solution. Okay? So whatever is more convenient, that's what you use for the axis. Let's continue. So here you have some examples. Instead of doing the examples, let's try to do an example which is not solved. So these ones you can take a look. Let's do one of the others. So this example here is, before I told you that we have a decoder from eggs to 7 segments. That's the example that we had before. In this example, we have a decoder from BCD to 7 segments. What's the difference between the eggs and the BCD? The BCD only shows digits, so only from 0 to 9. It doesn't show the letters that appeared on hexadecimal notation. So don't forget, hexadecimal goes 1, 0, 1, 2, blah, 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 9, A, B, C, D, E, F. So 16 values. This is hexadecimal. BCD is only 0, 1, 2, blah, 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 9. That's it. So when you have this combination, this in hexadecimal would be A, you don't care about it. This combination is irrelevant for a BCD decoder, okay? Because you don't want to represent the letter A in your display. So you can do something very similar to what we did before, taking into account these axes. Here's an example. Let's, for example, take a look at segment 4. So segment 4, again, the cardinal map for segment 4, you go to the table of truth, you fill in the x's, the zeros, and the ones, the zeros, and the x's now, because now we have 3 states in the table of truth. And you just fill them up, and then you just try to find the groups. For example, here we have constructed this very large green group by saying that all these x's are 1. Okay? We just use whatever suits us best. Any questions? Okay, let's continue. I will try to do an example. This one is solved, so we shouldn't worry about this one, because you can take a look. So here's some exercises. Let's, for example, do this exercise, okay? Let's try this one. So let me just take a screenshot. Okay, save. Now we go to the notes, save. I never forget to see the slide number. 81. Okay. So in this case, we have a single function, which is this one. So we don't have a function for segment 1, another for segment 2, and so on and so forth. We have a single function, so a single table of truth. And this is the table of truth. So we are just going to try to do the cardinal map and then the subsequent simplification. So first, the cardinal map. will be something like this. Let's see if I can. Um, dois, três, quatro, okay. Now, 1. So again, it doesn't really matter what I put, A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0. Be careful, because you cannot just say that this is the first, so you cannot pick up this one, put here, this one, put here, this one, put here. It's not like that, okay? The table of truth typically is organized in a way that it's like this. You put this one, that one, and then this one. This one, that one, and this. So don't count on the order. Always be sure to check if you are filling in the proper place. So let's start. This one here is 0, 0, 0, 0, 1. This one here is 0, 0, 0, 1. 0, 0, 1, 0. 1, 0, 0, 1, 0. So you see again, I did the first, the second, and then the fourth, and now I'm going to the third. Now 0, 0, 1, 1, X. 0, 1, 0, 0. Sorry, 0, 1, no, not this one. Now this one, 0, 1, 0, 1. This one, 0, 1, 1, 0. 1, 0, 0, 0. 1, 0, 0, 1. Sorry, no, this is an X, no? 1, 0, 0, 1, yeah, that's an X. Now we go here, 1, 0, 1, 0. And finally, 1, 1, 1, 0. Okay, so whatever I didn't do, so the remaining table cells are the zeros.
And teacher,
go ahead.
Tommaso, one thing, maybe the cell in 0, 0, 1, 0 is 0, no 1.
You say this one, no?
Yes.
Let's check.
Exactly.
So 0, 0, 0, 1, yeah. 0, 0, 1, 0 is, yeah, you're right. Thanks.
Oh, okay. No problem.
That's the only mistake I did? Yes, that is a miracle. Usually I do 7 mistakes for each cardinal map. Okay, so Tommaso, because you corrected my mistake, now you have the pleasure of selecting the groups. Go ahead. Some suggestions.
We can I can choose the first row.
The first row, okay. So first row, you mean like this? Or not?
No, like this. Yes,
okay, first row. What else?
And I don't know if it is correct to put the second column, the 1, 1, and the
X.
And the X, yes.
So you want it to do like this, right?
Yes.
It is not correct because you have to do 2 to the power of n. That means it is either 1, 2, 4 of size 1, 2, 4. So size 3 is not possible.
Okay. Perfect. Okay.
Let's undo. Let's undo. Come on. Doesn't work, undo. Yeah, it works. Okay. So the second group should be like this?
Yes.
Okay. Next.
The next is the last row.
Mm-hmm. Like this.
Yes.
Okay.
And
Anything else?
the last no. Okay, I think
it's finished, no?
Yes, it's finished.
All right. Now let's yeah, just a moment. Before you say something, I will ask your opinion, but just a moment, okay?
Okay, but that just okay.
Go ahead. Okay, so you were saying something. Tell me, what is your first group?
For me, okay, the first would be a square, the first line with the last line. We use that.
Okay, exactly like this, no?
Yeah.
Okay, good.
Then
what?
Would be the second column, the first 1, 1.
The same as Tommaso? So same second group, no?
Yeah.
Okay.
And I had a question. It's better for us to choose a group of 2 1s or a group with 1 1 and 1 X?
I think it's the same. So so you have option A and option B.
Yeah.
Option A is this one.
Yeah.
And option B is this one, right?
Yeah, exactly.
I think they are the same. That's why I said before that you reach functions which are the most simple, but it can be more than one. So if you select version A, you will have one of the versions, one of the most simplified versions, and the same if you have section. If you choose option B, you will have another most simplified version. Okay. But Tommaso, do you see that the colleague's solution is better, in particular for the red group? No.
Yes, exactly.
Better.
Is better. Yes.
Let's undo. Better because the group is bigger.
Yes.
We are very basic in automation, so bigger is better, period. It was a joke, no? Okay. Okay, so we have one group here, we have the second group there, and the third group, okay, I will select this one, okay? But it again, it can also be the other.
Okay, we can also put that one, the bottom corner in the right, with the on the top left corner.
Yeah,
right?
you mean this? You mean just a moment?
Just another option, for example.
Yeah.
You can always choose different
like
ones.
This? You mean like this? No.
No, I mean the bottom right with
Okay,
the top
right.
left corner.
You can? I don't think you can.
I'm just
no,
asking.
because you cannot do diagonal groups.
What? No, but I'm.
You are saying this. Let me see if I understand. You are saying this?
That and that. Yeah, just asking if I could do that.
But that's the same as doing like this, no?
Yeah, I know. Okay, because it
you cannot do diagonal groups.
Okay.
But let's go back and say, okay, so what is the orange?
No,
Tell me the function for the orange.
There's 2 bits that change.
Sorry?
No, just checking in the that you can do that. I just understood.
You cannot do it because otherwise you will not be able to derive the function, the min term for that. But what I was saying to Tomasi was this part here, that you could actually do this. So let's do the first version.
Teacher, but I don't understand. You cannot do that, but you can join the 4 corners. How is that possible?
Because the 4 corners are a square. They are not diagonal. It's, for example, it's like this. I think I can explain visually. So 0, 1, 1, 0, 0, 1, 1, 0. So you can do this group. Yeah. Good. But you cannot do this group. This is not possible, okay? It's
Okay.
the same in the corners, you see? If you do the square, no problem. If you just take one of the diagonals of the square, cannot be.
Okay.
Okay. Okay, so I was now going to derive the function. So the function would be, the red part will be not B, not B, not C, plus blue part. Blue part is not A, not C, D, plus, or now green part. Green part is okay. And now the second version, so let's call this the first version of the, so let's call this the green version of F. Now for the orange version of F, we have the orange will be A, C, not D. Okay, so I wanted to do this so you can see here we have two functions. And if I ask you what is the most simple function, they are both of the same simplicity. They are the most simple functions you can get for this problem in particular. And they are equivalent in terms of simplicity. So that's what I was saying when I said you can actually have more than one function, which is the most simple one. You just select one of those. Okay, here is a good case, a good example. Do you want to do another one, or we should just start programming? What do you prefer?
I prefer you do one more.
One more? Okay.
Yeah, me too.
Okay, let's go for another one. It should be fast also. So we will do the other, okay? Okay, slide 81. Okay. Okay. Now, let me just change position because my neck is hurting because of writing. Okay. Different position. Okay. So now, cardinal map once again. So let's just be crazy, okay? B, D, C, C, A, okay? Just to complicate things very much. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Oops, come on. Okay. Now, the problem here, you see, I put very weird things here. So the problem is that if I do it like this, it's very hard to go from the table to the cardinal map, but you can actually do it like this. For example, let's try. So the first row will be, so I have to read B, D, C, A. So this will be my first. D will be my second. C will be my third. And A will be my fourth. So I would have to go like this. 0, 0, 0, 0. So this is easy. 1. Then 0, 1, 0, 0. 0, 1, 0, 0. Okay, so we have two. Now, again, 0, 0, 1, 0. 0, 0, 1, 0. Oh, this is, sorry, this one doesn't, because we have a 0 here, it doesn't really matter. So now we go here. So here is 1, 0, 0, 0. 1, 0, 0, 0. Now this one. 1, 1, 0, 0. 1, 1, 0, 0. Moving on. 0, 0, 0, 1. 0, 0, 0, 1. 0, 0, 1, 1. 0, 0, 1, 1. And finally, no, we still have another. So 1, 0, 0, 1. 1, 0, 0, 1. Well, there are no x's here. This is, this doesn't have any x's, okay? This function doesn't have any x's. Okay, so we just do it without the don't cares. Or we can actually put some don't cares here just to make things more difficult. So let's replace this guy here with an x and this one also. So this one here will be 1, 1, 0, 1. 1, 1, 0, 1. X. This guy here. 1, 0, 1, 1. 1, 0, 1, 1. 1. And finally, this x will be 1, 1, 1, 1. Okay. Okay, so now we can put the zeros. And this was quite difficult because of the way I selected the order. I just wanted to make the case that you can really choose any order. So I will ask you to do at home the Carnot map. So at home you should do the Carnot map with A, B, C, D, and you should arrive to the same conclusion that we will arrive right now. Okay, so this is homework. Now let's proceed. Who wants to suggest some groups?
Can you repeat the homework, please, teacher?
Yeah, homework is doing.
Oh, it's on the right. Okay,
yeah,
okay.
It's here. It's here.
Okay, okay, thank you.
Yeah.
With the axis, all right?
With the sorry, what?
The axis.
Yeah, you can do with the axis. Yeah. Oh, well, the purpose is to prove that if you do this, it will be the same as that, right?
Okay.
So it has to be with the axis because the first one is done with the axis, right?
Okay.
Okay. So first group, who goes first? Who suggests something?
It could be the square with the x. It could be the square.
Which square? The square with the x?
No. 1, 1, and the first line and the last line. No.
This? Oh, sorry.
The first line, the 1, 1.
Okay, like this. Like this?
Yeah, that could be us.
Okay.
No, but I will do it with the middle ones.
Okay, so just a moment. So you want like this, right?
Yeah. Exactly.
Okay.
You want to make another group with the other 4.
I think this is the best solution. Let me see. Yeah, this is great because you get only 2 groups. That's the best one. So the x's here are just to confuse because you shouldn't use them. Yeah, best solution. So the function will be, the blue part is the red part is not D, and then this part here is A. Okay, makes sense. What time is it? Yeah. So for homework you should also arrive to this conclusion. Should be the same.
Teacher, even though we don't get to the same value, or better, we should get exactly to the same value, or we can get to an equivalent value, but with slightly different.
Yeah. So I think that in the cases where you actually have the more than one solution, which is the simplest, you will see it in any cardinal map. So if here we had some questions like we had before about selecting alternative 1 or alternative B, like the last exercise, then it means that there are more than one solution. There is more than one solution for the most simplified version of the function. In this case, there is only this alternative. I don't think you have any other alternative. So my expectance, so I expect that if you do it for the homework with a different cardinal map, you will also not have any other alternative, and therefore you will have to reach exactly this same function.
Okay.
Okay. What else? Yeah, let's do some programming. What I like is to program. So for the programming, what will we do? For the programming, let's try to implement this. I want to implement a decoder, an X decoder for 7 segments. And so it's important here that you already installed TIAPortal. Those of you which did not will be a bit delayed, of course. Moreover, I think I put a video on the web page in which I taught how to do small project examples. You remember this video? Did anyone see this video or not?
Which one, teacher? I'm sorry.
I will show it to you so you can refresh your memory. Let me just change screens. Save. Okay. Stop share. Okay. So share screen. Okay. And so drive. Okay, so here we have the PDF. The PDF, yes. And now we can go to e-learning. Learning, MyUC, SAI. So SAI, aulas teóricas. And here for class 2, you have a video for the introduction of the TIAPortal. Oh, sorry, not this one, this one. Not this one. Yeah, this one. We can download this TXT file. If you see here, there is a link for YouTube. And if you take a look at YouTube, oops, I didn't copy. Copy, paste. Okay, so this video here. So here I'm explaining how you can build project using the TIA Portal software from start to finish with some very simple examples. I teach how you can do, how you'll set up, configure the project, and then for a simple example, and then how you create the variables and do the programming with ladder language, and finally how you connect this to visual programming and how you simulate. So this is did anyone see this or not?
Yes, I saw it.
You saw it, okay. Because if you didn't see it, you will be, I think, a bit lost.
Yeah, I saw it.
You saw it too? Okay, good. Anyone else?
I didn't, but I already worked with the TIA Portal.
Okay, so you should be comfortable with it. Also with the HMI part?
No, but I will study this.
All right. Okay, so I will start assuming that you've seen this. Those of you who didn't, of course, will feel that I'm going too fast, but then you can go back and see the video, okay? And perhaps when you see the video, you will know what I'm doing in this example. So again, my goal will be to do this exercise. To do this exercise, which is an EGS decoder for 7 segments, okay? And of course, we have to derive the functions, all the functions for each of the 7 segments. So what I will do is I will do only for one of the segments, but I will set up the structure from which you can build upon. That will be homework number 2, which is to do this project for the EGS to 7 segment decoder, okay? Okay, so how do we do it? Let's start up a new project. I don't think we have time for a break. Do you really need a break, or do you want to finish a bit sooner? Do you want 5 minutes break?
I think
better. I don't need, but if anyone else wants that, it's fine for me.
I don't need.
Yeah, for me, you can keep on.
Keep on? Okay, keep on going. So TIA Portal.
Teacher, just one question. You're using the version 13. Can we use the 14 version, or it's?
If you don't use the one we recommend, might as well use the latest. So if you don't use 13, use 15. 14 is not a.
Actually, I have them all, but I usually worked on the 14th version.
So you have a reason for that.
It's the same or not?
I don't know. I've never used 15. They say it's faster, the version 15. I think you will be able to work on any of those. So if you can use our version, that way you know whatever we say can be applied. If not, you just use 15, I think.
Okay, then I'll use the same as you were using. So
okay. So we create a new project. This is the part where I'm going really fast because this was covered in the video that I sent. Projects. Now I'm going to create. So in this folder, this can be called EGS to 7 segment. Oops. Okay. Okay. I'm going fast because we only have half an hour, so I will try to be at least to give you a complete view of what the project should look like. So devices and networks, we will add a new device, which will be first a PLC. It's a SIMATIC CPU 12 ACDC RLY. So this is in the PDF that I've given you also. These instructions are there. I just know it by heart already, but you should check which is the device that we have. So here we have an eCPU. TIA portal is quite slow. I would say it's painfully slow. Okay, perhaps we can take the 5-minute break because of TIA portal. Okay, here we go. Now, after we have the PLC here, we have to configure the IP address for the PLC. And we have here in the PDF that I've given you. So I'm talking about this one. So this PDF here will tell you how to create a new project. We'll introduce the hardware, blah, blah, blah. So you see here, that's the one I was selecting. And then it says that we should select a CPU, an IP for the PLC based on this. And these are the 8 PLCs that we have in the laboratory. So let's just assume that we are on the first slot. So we are going to put this IP address for the PLC. So I select this communications port here, and I go to Ethernet addresses 161.114, and then I have to put 12. Okay, 12. Okay, so let's see if this is stored. Okay, so this is stored. Next, I add a new device, which will be the HMI 6 basic. This one, I think so. I'm not sure though. Okay. Be careful. You should really be sure about this. Otherwise, your project will behave strangely. Okay, I don't do this template. I just do everything I need afterwards. This is not, I think, the one I want.
It's the 7.
Yeah, I did something wrong. Let me delete the HMI and add a new device. 7. I selected 6. No, yeah. I was expecting to have only 2 options here. Thanks, Sarah.
You're welcome.
Okay, this is what I was expecting to see. Now we have 2 devices. These are 2 different machines, but they will communicate between them, between the 2 of them, in order to have to map the memory of one machine to the memory of the other. And the memory are the variables that you will declare. So it's possible to create variables in the HMI that will be constantly or periodically synchronized with the variables of the PLC. For that, we need a connection, and we create a connection by dragging from the communications port of the HMI to the communications port of the PLC, and we create a PN-IE connection. That's it. There is something else missing. I need to put the address for the HMI as well. 114.2. If you take a look here, the HMI address is this. Okay. Okay, so now we have our 2 devices created. Next step, to create some variables. So we go to PLC tags, and we can even create a new table. So this will be the eggs to 7 segment table. So a table just for our problem, which contains nothing. Now, for creating variables, we need to, so first, which variables do we need? We need the variables for the bits. Those will be the inputs. So if they are inputs, typically we create them on the addresses, on the memory addresses, which are related to the PLC's inputs. This part of the addresses is quite complex, but I don't want to go into that in detail about this. Otherwise, I will lose 20 minutes. So the question is that we need to create variables, and we need to say where they will be in the memory. And this is the address. Okay. We have 2 different types of memory. Which is a special memory, which is directly connected to the electrical inputs of the PLC's inputs. So that means, for example, I0.0 is a variable that will be 1 or 0 according to the voltage that I'm putting on a special pin which is connected to the I0.0. Then we have a second type of memory, which is the Q, and the Q are the outputs. So voltage, electrical voltage outputs. So if Q is somehow turned on by the program, then the voltage that we will have on that corresponding electrical output will be 24 volts. If the variable is false, then we have 0 volts. Those are the Qs, the second type of memory. Then we have a third type of memory, which is more traditional, which is the internal memory. So it has no direct mapping to any input or output of the PLC. Those are the M's, okay? And I will only say this for now. Next week we speak a bit more. So let me create all the variables we need. So these are the B's, so they are Y's. And now we have the 7 segments. So segment 1, but these segments will be not electrical outputs, but actually internal variables. And you say, why are they electrical? Why are they internal variables and not electrical outputs? Sorry, because we are not going to connect the PLC to any device, electrical device. We are going to see these segments, these lights, these LEDs on the HMI. So we have to map our variables from the PLC to the HMI, and therefore these variables can be internal variables of the PLC. So we have 7 segments, so we need 7 variables here. 4, 5, 6, 7. Okay. And that's just about what we need. This was, oh, don't forget to save a lot. Otherwise, I think on Saturday, I lost 1 hour of work because of this TIA portal stupid behavior. So now we created variables. Now we need to use them to build up a program. So the programs are here. We have the special function OB1, which is main function. This function always runs, and here are the instructions it's running. You should create other functions. I will create a new one, which is a function. I will call it FC15 outputs. And why I call it FC15 outputs is because we have some conventions that are used. I'm not sure if this is worldwide conventions or just for the professors that we have in the department. So we have 2 professors. One of them you will know. That's the one who will teach you the practical assignments, which have a very large experience in the industry. And in the industry, they use special conventions for naming the functions, for naming the variables, where the variables are in the memory banks. And this is one of the conventions. So Professor Raposo will then tell you a bit more about this. For now, let's just call it FC15 outputs. So this is another function, okay? And as I told you, only the main function runs automatically. So from the main function, we have to insert an instruction that calls FC15. So that calls the other function. And so we go to main. We are in main. No, yeah, we go to main, and here we create a call to FC15. So this will be call FC15 outputs, and we can even put a comment. This will call in every cycle FC15 function. Okay. Also, we can put a comment for our program. So this is main OB1. I always remember Obi-Wan Kenobi, the guy from Star Wars. This is the only function that runs automatically without needing to be called. Now runs periodically. Or runs is called periodically. Sorry. Okay. So we have titles for the blocks, comments, titles for each network, and then comments. Now now that we call function FC15, we can go here to the function. And So this will be implementation of the law. So logical functions for eggs to 7 segment display. Implementation of the logical functions deduced using Carnot maps. Okay. Implementation is not well written. Implementation. Oh, sorry. Okay. So now, first network, we will have to put here logical function for segment S1. And now we can do something here. I'm not sure. Let me check here something. I remember I have a PDF, not this one. SVP also no. Okay, so let me just share something here. So this guy here, I want to save it. No, not this guy here. I want to, yeah. This one. I'm going to save it to the shared folder. So my document, home, Dropbox. Okay, save. Now I should be able to see it from the client machine. Where is it? Yeah, here. Okay, so just a moment, please. Okay, so now we have here TIA portal, and on the left-hand side, the PDF we were studying. I'm just jumping all the way to the exercise we are doing. Okay, so now take a look. These are all the functions. This is the table of truth. No, not the table of truth. We still need to do the table of truth, but now we can derive the function. For example, for segment 1, then actually we will have to derive it for all the segments. Let's derive it for segment 1, for example. For deriving it for segment 1, we have to do it how? I'm just figuring out the best way to do it. I think I will share, let me see, what time is it? Half an hour. Okay, so I will not derive it for segment 1. I will use the derivation that we have done for segment 5. You remember we did it before? So that's the one I'm going to search. But for that, I will need to find it. Okay. We did it in the notes, no? Slide 81. No, I cannot find it. I'm searching in my tablet. Here. Okay, so I have it here for segment 3. So just to make sure I will have time, I will share this screen so you can see the derivation for segment 3. Actually, I can send this to my email and then show it to you. So let me send a PDF file, Gmail, to Miguel. Come on, Miguel. Okay. 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 So I should be receiving here an email. Okay. And this email . Okay, so now let me save this to Dropbox once again so I can see it in the Windows. Where is Dropbox? Dropbox, okay. Okay, so again, we go in search of the missing document, notes. Okay, so here we have the deduction for segment which segment is this? Segment 3, okay? So segment 3, which is here highlighted, will turn on when we have these particular combinations of input bits. How did we find out this? We just started filling in the cardinal map, but before that we had to do this part here. So this part here is like that. So number 0, when I write number 0, let me put here the red. So when I display number 0, so segment 3 will be activated. That's why we have a 1 there. For the number 1,
that's
it's
number
like this. Sorry?
That's number 8, teacher.
Sorry, that's number 8. Yeah, but segment 3 remains. Let me better to draw it here. Just a moment. Zoom. Yeah, you're right. That's number 8. But now that this is number 0, I think I can draw it better. Just a moment. So again, for number 0, I have this one, this one, this one, and the important one, which is this one. So this is segment 3, right? This is number 0. For number 1, we have this one off, this one off, this one off. This was off before, off, off, and now on will be this one on top. And then here we have again segment 3 on for number 1. And then we continue, for example, let's take a look at the last one. This one. For D we have, for D we also have this guy on. Then we have this guy, this, and this. So this is a D, okay? So that's how you fill the table of truth. You just take a look at each of these numbers, which are here. And for each of the numbers, you imagine the display and you see if it needs to be activated or not. That's what is represented in this part here. Okay, so you can also take a look at this, right? So you can say something like this. Oh, segment 3 is on in the 0, in the 1, in the 3, in the 4, in the 5, in the 6, in the 7, 8, 9, A, B, D, and that's it, okay? So all of these are used to create the table of truth, which is here. Then you use the table of truth to create the cardinal map. You create the groups to get the simplified version of the logical function, okay? Any questions so far? You will have to do this for all segments. I'm just trying to speed forward because I want to show other stuff. So after having this logical function, this is what you will need to implement in the TIA portal. So for example, for segment 3, let me copy here for segment 3. So logical function for segment 3. On for numbers. So for numbers 0, 1, 3, 4, 5, 6, 7, 8, 9, A, B, and D. Right? This is what we were just checking. Now, how do we go from the logical function to this. Oh, so we have here not, I cannot see properly, I have to zoom in. So not B3 and B2. So we go here, not B3 and B2. So B3, B2. Now another. Actually, 1, 2, 3, 4. I know that I will need 4, so I just press 4 times here. Now, not B1, not B3. Not B1, B3. Next, not B1, B0. So B0 is not negated, so I have to put here B1, B0. Next, the orange part, I'm doing the orange now. B0, not B3. So B is not negated. Now the yellow part, the last one. So B3, not B2. Okay. So now I just plug it all. So this is the ladder diagram. So this is the code, and you can read it. So you have to imagine the energy flowing from left to right. And if it reaches all the way to the left, we want to activate S3. So our output in this case will be S3. Okay. So activate segment S3 when this and this, or this and that, or that and that, and blah, blah, blah. Of course, now you will have to implement for all other segments. But for now, I'm just going to do the exercise just for this segment. So now we don't need the derivation anymore. We are going to close it. Close all tabs. No, let's not close anything. Let's just put it like this. And now we can actually take a look at this and simulate. So let's launch a PLC simulator. New project. So this project will be, I call this one eggs 2 7 segment. So I call this simulation. Okay. So the simulator, the PLC simulator, it's a program that is pretending to be a real PLC. So TIA Portal actually is deceived because it thinks that it's speaking to a real PLC, but in fact it's speaking to a program which is behaving as the real PLC, and that program is the PLC simulator. So how can we create a simulation? I already did. Now we go to sim tables. So here we are going to put the variables that we want to monitor or modify. So we can put here B0. First, we have to send the program that we built on our TIA Portal to the simulator. How do we do this? We go to compile. Okay, so 0 errors. Now we download to device. PLC sim is selected, so I think it should be able to find the simulator. The good thing is that what you are doing here is exactly the same that you will do when you have the real PLC in your hands. Okay, load. So now I'm actually sending the program from the TIA Portal on the right-hand side to the simulator on the left-hand side. Now this takes a while. The simulator will start moving, I think, in a moment. Yeah, now it's compiling, blah, blah, blah. Okay, so now we have the simulator actually running. So that is code, the code that I developed on the TIA Portal on the right. I transferred it to the PLC simulator on the left, And the PLC simulator is actually running the code because I cannot press the run. Now, the variables that the program that I've transferred has some variables, this B3, S3, so on and so forth. So I can actually take a look at them here.
Teacher,
Yeah?
one question.
Change the output. You change the output on TIA portal.
Oh, where? Here?
At the right, V0.
Ah, right. Thanks. I see. Now it's correct, no?
Yeah.
Does the simulation
Yes.
have to be in the same directory than the programming part, or
No,
could it?
doesn't need to. Actually, it creates a new folder with everything else. So it doesn't need to be on the same folder. Be one. So sorry. So 2 here and 3 here. Yeah. Now we can actually see here segment 3 also. So the code is running, and you can see here that segment 3 is on. Why? Because the 4 bits are all negated, are all 0. And when the 4 bits are all 0, we need to have segment 3 on. You see here, segment 3 should be on when we want to display a 0. Also, you have from this side of the TIA portal, you can actually monitor what's happening if you choose the glasses. Oops, something changed. You see here, it's not all green, it's blue and purple. It means that I've changed. What was the change? When I changed this S3 to something else and then back, it is saying, oh, you have a different program on the TIA portal, then you have downloaded. So I cannot monitor. So the solution is to download again. Okay, now I can monitor, and this is the monitoring result. Now, oh, sorry. So I'm actually turning on S3. So the energy that I was telling you about is the green part. So if it goes from left to right, it is able to turn on S3. For example, now it's going from left to right because B1 is false and B3 is false. So let me just turn on B1. Okay, if I turn on B1, by the way, this is number 2, and number 2 doesn't have the segment 3 on. Number 2, you see, segment 3 is off. What else? Okay, so now that's it. You just have to put all the other networks for all the other segments. And that's okay. So, and now I'm going to teach you very fast how you can do the visual programming which connects to this part. So I'm going to take the glasses away. Okay, but the PLC is still running. The simulation of the PLC is still running. So it's still running here. And now I'm going to create a program for downloading to the HMI device. So for the new device, it's here. So HMI. So actually I can collapse that one. Screens, root screen. So in the root screen, actually we always divide this into screens. So in the root screen, I should have a button which takes me to the other screen. First, let's create the second screen. This second screen should be with the name eggs to 7 segment. Okay. So root screen will have a button. Toolbox, buttons. The button will say, go to eggs to 7 segment. Okay. So I've just created a new entity, which is a button. And now I have to say what will happen when I press this button. So I select the object and I go to properties. So these are the properties of the object. And in this case, what I want to see are the events tab. And here I will define what will happen when something happens to the button, either when someone presses it or releases it or clicks it. Clicking is different from pressing or releasing because clicking means that I have to press and release. Only then a click will occur. And the click is a one shot. So you can only, if I press, I'm constantly pressing, so I have continuous or periodical press events. Clicking is just one shot. It's like a pulse. So when I click, I will run the function activate screen. And what is the name of the screen that I've just created? Eggs2 blah, blah, blah. Okay. So that's it. That's the first part. Second part, second screen. On this second screen, I want to see the following.
Oh.
Go ahead. Tell me.
No, nothing, teacher.
Okay. You were not very happy.
No,
So,
because my computer is really slower now. So I cannot catch the teacher.
okay, so B3 is the fourth bit. And now here we are going to turn this on if animations, display, we add a new animation of appearance. So we are going to change the appearance of the object circle. And what will change? The background color of the object will change if variable B3 from the PLC is on. But how come we can take a look at a variable from the PLC? This is a completely different device. And that's where the memory synchronization takes place. I'm going to create a variable in the HMI, which actually is mirroring a variable from the PLC. So here I can go and say that I want to go to the PLC tags, this table, and use variable B3. And I don't know if you, sorry, again. So here is B3, and now B3, if B3 is off, I want to use gray background color. If it's on, number one, I want to use, for example, green, signaling that B3 is on. So that's the animation we do. Just a curiosity, when we created B3, I told you that we have to take a look at an internal variable. What happened automatically is that it created an HMI variable, which is mirroring the PLC variable. Take a look. It created B3, which is a Boolean and has a connection to the PLC, okay? To the variable B3 from the PLC. This was done automatically when I selected a variable from the PLC. Okay, now I just replicate this stuff for the 4 buttons. Okay, so this will be B2, this will be B1, and this will be B0. B2 will also have an animation that doesn't take a look at variable B3, but at variable B2. Okay, that's the one, yeah. B1, the same for B1. Yeah, that's the one. And B0, the same for B0. Okay. Okay, so now we have these LEDs lighting up whenever we have the Bs turned on. Now we need our segment display. The segment display, I can use some rectangles. So this will be segment 1, segment something. I'm going fast because of the time. Of course, this could be more pretty, but the important part is to get to teach you the functionalities. Sorry, copy paste. Okay, paste. Actually, copy these two, paste there. Okay, so everything is turned off, and we are only working with segment 3, which is this one. So of course, then you will need to do for the other segments. Here is segment 3. So this object here will be turned on, properties, animations, add new animation, appearance. So this will be turned on when variable S3 is on. Sorry, so it's gray when it's off. It will be green, or let's use the red because this typically is colored red when it's on. Okay. Sorry for going fast, but I wanted to teach everything. So now that we have built our program just for segment 3, we can actually compile it. So we have an error, HMI connection. Yeah, typically when this occurs, what I do is I delete this connection and I create it again. And go back here. Actually, I will select the screens for compilation. And voila, I don't know what happened. It's a bit stupid, I know, but it works. So now that the compilation worked with 0 errors, I start the simulation of the HMI. So we have 2 devices, so we need 2 simulations, which actually will speak to each other. This is how you start the simulation for the HMI. You need to have selected the HMI tree. So this is what will actually appear on the HMI when I run it. So this is the main screen. I say go to second segment, and it's here. So look, it says B1 is on. It's true. The PLC simulator is putting that variable on. If I put, for example, B3 also on, it will say, oh, these 2 are on. And this is number, I don't know which number is this. We can try to take a look. Sorry. Let's try to take a look at which number we are talking about. So this will be 0, 1, 0, 1. So 0. Here, this is A, okay? You see 0, 1, 0, 1. So A should be something like this. And of course, segment 3 should be on, and it is on. So it seems to be working for A. Let's try some other number. Let's try number 0, everything off. So everything off is the case 0, 0, sorry, from right to left, 0, 0, 0, 0. And 0, 0, 0, 0 is for number 0. And number 0 should be, you know how it should be. And segment 3 again should be on. For example, let's try for the F. So F is when everything is on. So 1, 1, 1, 1 is F. And F should have segment 3 off. You see here the F on the, here the F, okay? So segment 3 here is off. So let's turn on here all the B's. So we have F and it's off. So it's working as intended. You just have to expand it for the other segments. Any questions? I think I went too fast, no?
I don't think so, but as I said it before, I know this program. Even the HMI, it's not that difficult. So
yeah, okay. So I'm glad. Yeah, go ahead.
The problem was that I think teacher's computer is really fast. So
it's good to blame the computer, not the teacher. That's a good solution. Okay, but the good thing is that I will put this video online and you can watch it again, okay?
Yeah, that's it. It will be better once we'll be watching this with a little bit more calmer, and then, but just for this explanation, I think I understand the basics of it, yeah.
Okay, okay.
Yeah,
more comments? Okay, so
teacher, one question. I wasn't paying enough attention, and I didn't notice if the simulator you used is on the TIA Portal program, or it's a program, you know, outside the TIA Portal.
For the PLC simulator, so we are using 2 simulations. One for the PLC, and yes, it is an outside program. And then for the HMI simulation, which is this window, we launched it from the TIA Portal. We pressed this button here, where my mouse is. And so we are using, so the answer is both. one of the simulators, it's an outside program.
Yeah,
the
yeah,
other
okay.
is inside the TIA portal.
Okay.
Actually, I think TIA portal, what it does is call something called WinCC, which is here. I think, and I think this is also an outside program, but we press it here. Okay.
Okay.
What else? So am I going to see a 7 eggs to 7 segment display next week?
Yeah, if you could answer a question. It's not about
blackmailing you. You are blackmailing.
No, no. It's not about the TIA portal, but it's about the VirtualBox. You said that we need an extension pack. I started the VirtualBox because I already have, and I updated to 6.1.14, I guess.
Okay.
And I can't find the extension pack for 14. Yeah.
I use Linux, so I don't know if. So I'm still in VirtualBox 5 because I'm in Linux. Oh, sorry. Where is the extension?
If I use the 6.16.
Yeah, it's here. VirtualBox extension pack, no?
But I have 14.
So just install the new VirtualBox, perhaps. Do an update.
And where I can install the new, it's on platform or software developer.
Well, it's here. You just download one of these and then install. So you have a Windows?
Yes, yes, I have.
It's this one. Windows hosts. Download it and then download this one and install. Yeah, it's just that.
Okay, okay.
Okay.
So I will do this right now.
This and the eggs to 7 segment, because now you're blackmail. Yeah. Now you have to do it.
Answer my questions, so I need to do the
exactly
the program now. No problem.
Okay. More questions. Okay, everybody. If you need some help over the week, send me an email. I will try to help if I can. Again, I'm still quite busy these weeks, but to send me an email. Usually, I am able to answer in fast. So just send me an email if you need. Don't forget to, when you are sending an email for calling for help, be sure that you try the what you can think of for solving the problem. The only thing I don't like about emails asking for help is when I clearly say this guy didn't even try. He just asks me to help him, and he didn't even bother to do some work. That's let's say a bad call for help. A good call for help is saying, oh, this is not working. I've tried this. I've searched for that. This solution doesn't work because X. Then I saw solution Y. It also didn't work because of Z. Now I need your help. This is a good call for help. A bad call for help is one, for example, I received an email last week of a student that said, it doesn't work. Here's the picture. I took a picture. You see what's happening. This is not a good email, okay? That's it. I don't have anything else to say. I will try to upload the video as soon as I can, and we meet next week. Okay?
Teacher,
go ahead.
Do you remember I had 2 questions from the equations in the beginning?
I remember. And this, okay, but this, okay, go ahead. Tell me the question. The questions were just to solve the exercises.
No, it's some questions I had when I was studying.
Okay, go ahead. What is the? So if it is the equations, we can actually go back to the tablet mode.
No, I don't think that's necessary.
Okay, so tell me. Ask away.
The first one is, for example, if we have, there's a rule that says that A times A negative, it's 0, right?
Mm-hmm. Yeah.
But what if I have A negative times B negative times A times B? Do you understand?
Okay. I did, but I have to write it down. Just a moment.
Okay, that's...
Okay. Give me a second. Sorry, just a moment. Ok. Just a moment. Oh, Daniel, podes entrar aqui se quiseres, pá. Entra aqui. Sorry, my kid needs to pick up some toy. Pega lá no teu brinquedo. Ah, esse. Vê lá se não deixas isso cair, pá. Ai, ai, ai. Tá, vai à tua vida. Com cuidado, não deixes isso cair. Okay, so tablet mode. Just a moment. Screen. Start. New. Back. New. Oops, sorry. New. Okay, so okay, so you said if I have not A and B times what?
Not A, not B.
Yeah. Again?
No. You have not A and not B. Okay. Times A, B.
So you can do it in multiple ways, but you know that so A times not A times A is 0.
Okay. Yeah.
And
So
0 times anything else will be 0.
Okay.
So or you can also say that this is also 0, but 0 is what is called the absorbing element of the ends, no? I
Yeah.
cannot say false and whatever. Whatever doesn't matter, because if it's false and whatever, because the first is false, everything, it will always be false, the result, no? That's what it means to say if we have a 0 here, everything else goes to 0.
Okay. And in the case of adding,
Adding, for adding, the absorbing element is 1. So this is called the absorbing element, which is the 0 for the end. For the OR, it's the 1. Look, if I have 1 or A, this goes to 1.
Yeah.
So basically A is absorbed.
Yeah, sure. But my question is, for example, when you have A plus a negative, you have 1.
Mm-hmm.
Right?
This is not because of this rule. This is because you are covering all the possibilities.
Yeah, 1 has to be 0, 1 has to be 1. I understand.
Therefore, the result is always 1.
Okay. And when I have, for example, A times B plus A negative times B negative. Exactly.
I think you cannot. I don't think you cannot do anything.
Okay. Okay.
This is I don't, unless I'm missing something. This is not simplifiable.
Okay.
I think anyone else can see a simplification, but I don't think so. Well, if someone can, please tell me. But I don't see a simplification here. You know what, Martin? Look. AB is 1, 1. Right, Martin?
Mm-hmm.
Not A, not B, 0, 0. Okay? So you cannot do any group. So the only way to take into account these 2 ones is to do 2 groups, which is what you have here.
Yeah.
So it's not possible to further simplify.
Yeah, that makes sense. Okay.
Okay?
Yeah.
Any more questions?
No, I don't think so.
Okay.
Then it would be nice if the teacher can find the last exercise, the one that we weren't able to do.
Yeah, send me an email so I don't forget, okay?
Okay.
Please send me an email, so otherwise I will forget. Okay, so don't forget to study. You can see that these classes move fast because 3 hours is a lot of time. So be sure not to forget to do the stuff you should do, both from the theoretical and the practical part. And then let's talk next week. Send an email if you need, okay? See you next week, guys and girls.
See you next week.
Dear teacher.
Bye
Have a
bye.
nice weekend.
You too.
See ya.
See you.